For years, astronomers have been watching one of the brightest, most mysterious stars in the night sky. Betelgeuse, a red supergiant on the edge of collapse. They said it was coming. They just didn't know when. Now, the James Webb Space Telescope has captured what no one was sure we'd ever see. The moment Betelgeuse began to explode. A stellar death, a cosmic shock wave, and a window into the raw power of the universe itself. This isn't just another deep space observation. This is a once-in-a-lifetime event, the closest supernova humanity has ever recorded. And what Webb saw has changed everything. Betelgeuse, located in the shoulder of the Orion constellation, is no ordinary star. It's a red supergiant, more than 700 times the size of our Sun and roughly 20 times as massive. For decades, scientists have known it was unstable, swelling, dimming, erupting. In 2019, it suddenly faded, triggering global speculation. Was this the final moment? Was it going supernova? Now, with the Webb telescope's precision, the mystery has deepened. For the first time, we're seeing real-time indicators of a star and collapse. Massive energy discharges, shifting surface convection, and magnetic fields twisting into chaos. Betelgeuse isn't just dying. It's transforming right before our eyes. The James Webb Telescope has been focused on Betelgeuse for months, using its infrared vision to peer into layers invisible to any previous observatory. And now the data is in. What it shows is stunning. We can see convective bubbles the size of Jupiter bursting on the surface. We can trace plumes of hot gas streaming into space at unimaginable speed. And hidden within the light spectrum, a signature shock wave moving through the star's outer layers. For the first time ever, astronomers are observing the actual physics of a star tearing itself apart. This isn't a simulation. It's the real-time anatomy of a supernova. And it's happening just 642 light-years from Earth. Unlike other supernovae that occur in far-off galaxies, Betelgeuse is close. Cosmically speaking, its explosion will eventually be so bright it could be visible during the day, brighter than the full moon. But more importantly, its proximity gives scientists a once-in-a-generation opportunity to study the death of a star up close. How its core collapses. How elements like carbon and oxygen are forged. How the shock wave reshapes the surrounding space. What Webb captured isn't just a star dying. It's the very process that creates the ingredients for life. The same elements that formed Earth and us. We're watching our cosmic ancestry in reverse. The Betelgeuse explosion is more than a spectacle. It's a key, unlocking the hidden processes behind galaxy formation, planetary systems, and the cycle of life in the universe. Through Webb's advanced instruments, we can now model the final stages of stellar evolution with unmatched precision. We can finally understand what happens inside a star as it dies. And we may even learn what signals to look for in others, possibly predicting future supernovae long before they happen. This is not just science, it's revelation. A moment where humanity looked into the abyss of time and saw the light explode. The explosion of Betelgeuse is not a singular event. It sends shock waves across light-years, disturbing the surrounding interstellar medium. Already, Webb has detected the early ripples. High-energy particles moving outward, heating surrounding gas clouds and altering the shape of the star's dust halo. But there's something else, a gravitational shift. Even from 642 light-years away, the collapse of Betelgeuse's core may have sent out gravitational waves, the kind we've only just begun to detect. If confirmed, this would mark the first time we've linked a visible supernova with direct gravitational data. And that would rewrite everything we know about the interaction between light, matter, and space. As Betelgeuse collapses, one of the greatest cosmic questions reemerges. What's left behind? A neutron star, a black hole, or something stranger. The data from Webb suggests that Betelgeuse's collapse may not be entirely uniform. There are magnetic field disruptions, plasma voids, and a possible asymmetric fallback where material doesn't escape into space, but is drawn back inward. Some astrophysicists are even speculating about a transitional object, a phenomenon that sits between a neutron star and black hole, theorized but never observed. If Webb has caught this in action, it would be the first direct evidence of a new class of cosmic object. With a star exploding just 642 light-years away, many have asked, are we in danger? The short answer is no. Betelgeuse isn't close enough to harm Earth, but the longer answer is more complex. The explosion will release a wave of high-energy particles, gamma radiation, and expanding electromagnetic bursts. These could potentially disrupt cosmic dust clouds, influence other star systems, even trigger changes in how light from other regions reaches us. For now, WEB is closely monitoring the velocity and spread of this radiation front, because even if we're safe, the explosion may alter the optical structure of our galactic neighborhood, changing how we observe the universe from here on out. Betelgeuse is massive, ancient, powerful, and yet it's dying. A reminder that even stars, those eternal lights in our sky, have limits. What Webb has captured isn't just the death of a star. It's a cosmic mirror held up to us. Everything that lives ends, but in that end, new elements are born. New stars will rise from Betelgeuse's ashes. New worlds may form in the chaos it leaves behind. This is not destruction. This is cosmic renewal, and we were lucky enough to witness it. Among the vast data collected by the James Webb Telescope, scientists discovered something unexpected: variations in the elemental composition of the ejected material. The explosion of Betelgeuse is releasing not just carbon, oxygen, and iron, but rare elements like technetium and yttrium formed only in extreme stellar environments. Why is this significant? Because analyzing the ratios of these elements allows scientists to trace the life cycle of matter in our galaxy, from the core of dying stars to the dust that forms planets to the atoms inside you and me. Webb isn't just recording an explosion. It's decoding the chemical script of how life becomes possible. And Betelgeuse, in its final moment, is telling a story that began long before Earth existed. Betelgeuse will never return. Its place in Orion will become an expanding cloud of superheated gas and glowing debris. But its death isn't an end. It's a gift of knowledge, of elements, of perspective. It reminds us that our sun, too, will one day fade, that even the most brilliant lights in the sky have a final act. And yet from this ending comes the blueprint for everything new. Because without supernovae, there are no planets, no oceans, no life. And now, thanks to the James Webb Telescope, we can finally witness that full cycle from fiery collapse to the raw materials of creation in the cold silence of space. 642 light-years from Earth, a star has ended its life. Not with a whisper, but with a brilliant final roar that traveled through the dark for centuries until it reached us. Thanks to the James Webb Space Telescope, we didn't just see it. We understood it. We saw the signs, the collapse, the detonation. Not as myth, not as metaphor, but as fact. Betelgeuse didn't die in vain. In its final moment, it gave us answers to questions older than humanity itself. Where do the elements come from? How do stars live and die? And what will happen to our own sun? In that fading red light, Webb has captured more than a supernova. It captured our origin story and a glimpse of our future. So now we ask, what else is the universe ready to show us? And are we truly prepared to witness it? Let us know what you think in the comments. Was this the most important stellar event of our time? And what will be the next cosmic secret the James Webb Telescope reveals. Subscribe and turn on notifications because this isn't the end. It's the beginning of what comes after the stars.